All right. That should be back. Yeah. Got my social stream stuff to connect again. We are back. Is the lag still bad, or is the lag done? Is the lag fucking awful? Okay, the lag is fixed temporarily though, because now I'm going to try to fire up all my other services real quick. Let's see if we can get it to work. And then I'm going to try something new here, actually. I'm going to reset this. I'm going to copy this. Go to my settings. And then let's go. Must have been the wind. I just want to see if I got this working. Nice. Okay. We're back there. Cool. Let me see if I get Twitch running again real quick. It is a weird thing, dude. Like, just resetting your router, I think, just reprioritizes your signal. And I think especially as it starts rolling around like 5 o'clock here, everyone's getting home and just trying to watch whatever, like Desperate Housewives or whatever the fuck. And that's unfortunately like eating my bandwidth. So I have to like remind the tower that like, no. I get priority. But I think eventually figures it out. Cut their wires? Yeah, right. I really should, honestly. Okay. Let's see. And we're back. Yes. No. My clock is 2 minutes ahead? Really? Why is it 2 minutes ahead? I don't think it's 2 minutes ahead. So I can't... Come on. TikTok. I'm in the future. It's true. I am in the future, dude. Okay, cool. Seems to be working now. Happy. All right, let's try to do this question. Rectangular boxes in here. Come with me if you want to math. Okay. Find the dimensions of the box with the maximum volume. Okay. Okay. Well, I'm assuming it has to have one corner at x equals 0, y equals 0, z equals 0, right? That's probably the only way to get the maximum volume, yeah? It's for us to, like, have a point there at least. Streaming dying? No, streaming isn't dying. My internet connection, I need to reset it. You know, and actually, I've had this thought. I think I am going to start doing this on streams where, and Eric does this already, and I really like this. He has, like, breaks. He's like, okay, we're taking a 5-minute break. Like, just go to the bathroom, go put on some deodorant, like, get a snack or a coffee or something. And I think I'm going to use that to reset my internet on, like, the 5-minute breaks. And I'll do it at, like, the 2-hour mark, I think. Is this Calculus 3? I think it is kind of Calculus 3. Yeah, it is definitely multivariable. So there definitely is, like, some Calc 3 vibes going on here for sure. Okay. So if the corner is here, then volume is equal to x, y, z, right? which we have to maximize. So here, we want to maximize V on the restraint. Yeah, we could do that if we want to, Kinshuk. Yeah, that's just Gauss's law. Right? All right, so how do we do this? Fedvox says it's a Lagrange multiplier. Interesting. Why do we think that? Oh, because we have a restraint. Yeah, okay. Okay, I gotta remember how to do Lagrange multipliers. Okay. So we're going to use Lagrange multipliers. Okay. How does this work again? I think it's like this fancy L thing, right? Yeah, L, X, comma, Y, comma, Z, comma, lambda is equal to f of X minus lambda times whatever like the restraint is, right? And I think we set the restraint equal to 0, right? So here, this would be X plus Y plus Z minus 6 is equal to 0, right? Okay. It's plus lambda? Is it? I mean, I don't think it matters, right? Lambda will just be positive or negative. You are right. They do like plus. Okay, that's cool. We can do plus. Fedvox says it doesn't matter. Well, because look at this one here, Bertram. Right? They apparently like doing minus. I think Femvox is right, though, that it doesn't really matter whether it's plus or minus, because lambda will just change to be plus or minus. Yeah, well, this is kind of a linear algebra question for sure, right? Oh, no, you're cool. No, I appreciate it. No, good bringing up that point, because, yeah, if I'm wrong, I want to know whether I'm wrong or not. You're good. Okay, X plus Y plus Z minus 6. Okay, cool. And then we have to calculate the partials, right? So partial, if I can draw this fancy L again. Partial L, partial X. So that's going to be equal to YZ. So you hold X as the only thing you're taking derivative of. So that's YZ minus lambda, right? Oh, you're doing it for economics. That's very cool. Yeah, Lagrange multipliers. I've started seeing them a lot on my stream as, like, questions. Only, like, the last week or so. I think it's because a lot of students are starting to get into them. Okay, there's going to be a lot of symmetry here, right? This is just XZ minus lambda. And then delta Z is going to be equal to XY minus lambda. And then, I guess, do we also take the partial with respect to lambda? Can you do polynomials? Yeah, I mean, this is a polynomial. I mean, it's kind of, well, it's not really a polynomial, but. How are you writing this cleanly? I have a pen. I have a stylus. I'm not doing this with my fingers. It'll take forever. Okay, this is just X plus Y plus Z minus 6. Okay, all right, and we set these all equal to 0. That's what we do. Okay, cool, fine. Need help? Submit a screenshot. Actualofficehours.com. Go do it. I have like another 45 minutes that I'll work with you guys, and then I gotta go. But also, you can find the schedule of when we're online, and feel free to come by that as well. Okay, so from this, I think if I rearrange these, that just tells me that lambda is equal to YZ, which is equal to XZ, which is equal to XY, right? Okay. I think the only way for this to be true is for X to equal Y to equal Z, right? Right? There's no way for this, like, round robin of pairs to equal each other unless X and Y and Z all equal the same thing, right? Okay. And then from here, that just tells me, right, that 3x minus 6 equals 0. Oh, cool. So X equals 2. And then Y equals 2. And then Z equals 2. Oh, dope. Okay. Very cool. All right. So then the volume. So volume is equal to 2 times 2 times 2, which is equal to 8. And you're done. Nice. Good job. Kind of a cool question.
Well done.
Whose question was this, by the way? Is this Jeb's? This is Jeb's. Jeb. I think Jeb, you asked me a question earlier today. Jeb 2. Oh, you can skip my question if you want. It's just for fun. Okay. Yeah, yeah. No, I appreciate it, Femvox. If you want, Fem, I'll put it on. I always need a question to start the stream off with to, like, kind of, like, seed the pot, you know? I'm happy to put yours as, like, for tomorrow's, like, starting question. I just need to be seen, like, doing something. And then the YouTube Twitch gods or whatever are like, oh, okay, yeah, like, start sending in people. It's like the tip jar, you know, if you were working at a bar or something. Sorry, and where is... Yeah, so let me clear that question. What is the only set of consecutive natural numbers whose sum is 296? Wow. It's kind of a fun one. All right. Let's see. Perry, are you still here? Teague says he uploaded his as well. Yep, I see it. So, is Perry still watching? Let me just go through, like, what the questions are. Perry was asking about Lewis structures for HCl4-. Well, these aren't, these are ionic compounds. So I don't really think you make Lewis structures for these. Cl2O2 you can kind of do it for, I guess. Okay, what was this one? Ooh. Oh, man. This might be tough. Assume there's a function f of xy is cosine y sine xy whose region is bound by the paraboloid. Find the surface area. Is this the same thing? Like Lagrange multipliers? Because I see something that's bounded, right? There's a function whose region is bounded by that, right? Yeah? I feel like this is another Lagrange multipliers question. Everyone's asking me Lagrange multipliers today. And then here, let me just see what the other ones are. Just real quick before I start getting into stuff. This is a great one. Yeah, this is easy. I can do that one. That's not too bad, Makoto. Lol says I'm still here. Lol is still here. Okay. We can do that. Yeah, maybe I can do that one. That would be pretty easy. And then, what was this? 4x thing. Dude, having to, like, read like what this is. Evaluate the following integrals using partial fractions. Oh, well, I need to see the other part of this. Oh, 4xb. I can't see all of it. Oh, there we go. Okay, partial fraction. That's a cool one. Makoto says he's also here. Okay. All right, Makoto, let me do yours. And then, just because I'm going to prioritize people that are here right now. I appreciate you waiting a while. Makoto, you've been here since almost an hour. And then I'll do the other ones. But this one might be a little tricky. This one I think I can do. I think this is not too bad. Uniform slender bar. Slender bar. It's like Slender Man, but slender bar. Mass M has length L. Determine the gravitational force it exerts on a point particle M shown below. Cool. Makoto, can I use calculus on this? I feel like what I want to do. I can. Cool. Because force of gravity between like 2 point charges or 2 point masses is equal to G M1 M2 over R squared, right? And then what I'm going to do is I'm going to integrate dm. You kind of have to. Yeah, I agree so. Okay. Yeah. So I'm M1. I'm going to say it's just equal to M. That's cool. But then M2 is going to be equal to, we're going to call like DM2. So here, we're going to say G, M, integral, and then this is going to be dm over r squared. Where this is, what we're doing here, Makoto, is I'm pretending that this bar is a bunch of little point masses. Okay? And then we're just going to integrate all of them. And then like what gravitational force they exert on this little m here. That's how we're going to do it. Okay. So dm is equal to lambda dx, where this is going to be equal to m over L. So this is like linear mass density. Dx is like the little individual dx that I'm going to integrate over. Like as I add these all up, where we multiply this density by like its little like width of dx. And then we're going to integrate this from, I'm going to say from, this is interesting. I have to choose a coordinate system here, right? So I'm going to choose this to be x equals 0. So I'm going to integrate from 0 to L. And then this is dx. So, okay, this is going to be g little m integral from 0 to L of lambda dx. So that's m over, or here we can leave the lambda is also a constant, which is not, the lambda does not depend on x. So we can eventually pull it out. So lambda dx over r squared. And then here's the tricky thing, okay? So as I go in my integrand looking at all these different dx's, so like, let's say here, this is like, you know, x equals something, right? And we're integrating that little mass there. R is going to be equal to z plus x. You're very welcome, Femvox. Have a good luck. Have a good time at the grocery store. Okay. So this right here has to be equal to z plus x, because r refers to the distance between the 2 point masses. So between my little mass m and my little slice of the bar, which we're calling like this dm in the integrand, that distance is z plus the x coordinate of where I'm adding up my little point masses in the bar. Does that make sense, Makoto? Sorry. Let me know. It gets kind of confusing sometimes. The nice thing is that your lambda does not depend on. Yeah, good. Okay, does it make sense? Cool, great. Sometimes this depends on x, and it will like start messing up the integrand. Okay, so that's this, and then we have integral from 0 to L, and then that's dx over z plus x squared. Oh, okay. I think I have to do partial fractions here, right? This is not a trivial integral to do, right? Okay. Z is a constant, Jeff. Oh, you're right. I can just do u sub. No, we can do u sub. Sorry. U is equal to z plus x, so du is equal to dx. Duh. I'm kind of silly here. Okay, so this is 0 to L. Don't worry about the bounds yet. So this is going to be du over u squared. So then the integral of that will be negative 1 over u, right? So then we have so here, I'll show you. Sorry. Don't worry about the bounds. The bounds change when I do u sub, technically. So this is going to be du over u squared. And then the integral of that is equal to negative 1 over u. But then I'm going to replace what u was, which was z plus x, right? So that's going to be 1 over z plus x. And then we're evaluating that from 0 to L. Right? Because that's what my initial bounds were there. Yeah, so you don't have to trig sub. You would trig sub, David, if you had the integral of like dx and it was 1 plus x squared. This is definitely a trig sub situation. Yeah. Negative sign. Thank you. Thank you, Wiza. Yeah, you're so right. Okay, cool. So, that's going to be this. And then that's going to be negative 1 over z plus L plus 1 over z. Right? Okay. Okay. So, yeah. G, little m, big M over L. And then that's going to be 1 over z minus 1 over z plus L. I think that's correct. Looks pretty standard, no? I can throw it in ChatGPT real quick, just to see what it says. It's kind of fun. Which way is the best? What is the best way of self-teaching Calc 1? Whatever works for you, honestly. Some people do very well with reading textbooks. Nowadays, people don't really like to read things. So sometimes having more of like a visual way of learning calculus. I know there are a bunch of videos that people have of lectures or like learning little topics in like short form. I do those a lot on like YouTube and TikTok. But if you want to like make sure you understand something, you should make sure you can do problems. So I think the best way to learn is to do. So by like doing practice problems in should help you out. Okay, cool. Wait, here we go. I think this is what they got. All right, let's see. Makoto says final answer is GMM over Z plus. Yeah, and I think that is correct there. I'm going to show you why, Makoto. If I combine these, let's combine these fractions, right? So this is going to be Z plus L over Z plus L. And then this is going to be Z over Z. So then this whole thing turns into Z plus L minus Z over Z times Z plus L, right? So Z's cancel. And then this L will cancel with this. And then so you get G big M little m over Z plus L. Which, yes, that's the correct answer you got according to your book. So, yeah, nice. Good job. Sick.
Well done.
Nice. You're very welcome, Makoto. Thanks for hanging out. I know sometimes the queue gets kind of long. I'm going to post this in our Discord, so if you want the solutions for it, I'll do a little post here. I'll say Makoto, and then we'll drag your file in. Office hours. It's all right, worth the wait, man. Oh, I appreciate that. Yeah. But there it is. Cool. Good question. I like it. I like the calculus part of it. It's cool. Fran says, yo, I have a question. I take advanced functions and had to factor polynomials. Is it bad that my long division symbol looks like a square root sign? I mean, just get rid of the little hook. You're fine. Psycode, what's up, dude? Yes, if the linear density is constant, correct. And the nice thing here was I think they said that it was uniform, right? A lot of times things won't be uniform, though, especially if you do E&M type questions with this. And so all that happens is this lambda is usually a function of x, which then will do some goofy things on the integral. Can you see? Yeah, this is the queue so far. So wait, let me go through who I can actually take some people off the queue because they've already answered. I've got that to look forward to. Yeah, E&M is great. I love E&M, dude. E&M is fantastic. Sorry. Yeah, let me go through. Okay, so I don't think Perry's here anymore. I'm gonna mark that off. I don't think Calcul is here. Makoto we just worked with. So next would be LOL. Dom is here. Dom, which username did you put your thing as? Because there's a lot of usernames here. This is why it also helps if you put the same username on your on whatever social media platform you are as you're submitting here. Oh, Calcul's you. Okay, so then, sorry, let me do Calcul's then. Sorry. I'm glad you're here. How can I deal with India JEE advanced questions? Dude, those things are absolutely just like painful. JEE is really, they ratchet the difficulty so high because they know there are so many people competing for so like few spots to go to like top universities. It's like, from my point of view, it's brutal. And if you were to give like JEE questions to most like students in the US, they would never do physics ever again. Because they're just, I don't know, they just suck the fun out of everything. Yeah. Okay, cool. All right, let me see if I can do this one real quick. Y'all asking some more advanced questions for sure. Testing my math knowledge these days. Okay. All right, a paraboloid. Bounded by, so wait, what does this paraboloid look like? X squared plus y, I mean, this kind of looks like a circle to me, right? I mean, if you're 1 billion plus people, even if you're 1 in a million, there's 1,000 people just as good. Yeah, that's why. It's rough. Yeah, I'm sorry if you lost the genetic lottery of getting born in India. Just from the competition standpoint, I understand it's brutal, man. Like, there's so many people, everyone's trying to escape poverty, so they just create an insanely difficult exam to see who, like, really wants it. Yeah. A circle of radius square root of 14 minus 7. Ooh, I like that. Ooh, that's actually very cool, Jeff. I really like that. Psycode says it's an ellipsoid bowl. Yeah, I mean, so when I see this, I see, right, yeah, z minus 14. This does kind of look like, because usually we have x squared plus y squared is equal to r squared, right? So, this is, I could think about in like 3D shape, this is where like r is equal to the square root of z minus 14. So I think that kind of tells me how it's bounded, right? Because if z is 14, then the radius is 0. Okay, so I think I kind of see what happens here. Sorry, did I do that wrong? Sorry, 14 minus z. Thank you. Sorry, I make mistakes too. Psycho, did I see you at TwitchCon this weekend? I met so many people at TwitchCon. It was such an awesome experience. I'm definitely going again next year. So cool. No, not really? Okay. Well, welcome. Do I follow you, Psycode? Do you do like science coding stuff? Here, I'll give you a follow anyways. Oh, you don't know? Okay, whatever. I give you a follow. Just a random dude. All right, we're all just random dudes on the internet. That or we're FBI agents. What is a paraboloid? Cool. So a paraboloid is like a 3D parabola. So if you guys remember from, what is it, like pre-calc, right? You guys remember learning conic sections, right? This is a parabola. There you go. Kind of look at it. You can do so here. That has the cement for it. Yeah, we could use GeoGebra to graph it as well. So this is a parabola. And then a paraboloid looks like this. So it's like a parabola in 3D. Pretty cool. Okay. Hard or easy? Well, hopefully something I can help you with. I hope it's not too hard. Okay, it's bounded by this. Okay. Find the surface area of the region bounded by the given paraboloid. I feel like surface area, I need to always do like some like dA, and dA is always like tangent to the volume. No, I assume it's 0. Yeah, I assume it's z equals 0. Or because otherwise the surface area would be infinite, no? But here's the cool thing. Right? That's a good idea, Nico. Yeah, you could think of it as a parabola that's just being rotated around an axis. That works as well. Okay. Assume there exists a function. Okay. Find the surface area. So usually when we do surface area, it's the integral. It's kind of like arc length, but it's in 2 dimensions. I think surface area has this form. Correct me if I'm wrong. I think it's like the double integral over some domain, and then it's the 1 plus like df dx squared plus df dy squared. Is that it? Is that kind of like the area? And then this is like dA. Yes, it's a Pythagorean formula for length. Yeah, exactly. Okay. Yeah. So you're taking arc length and just doing it in 2 dimensions. Okay. Yeah, right? Yeah, I guess so. Well, okay. All right. Okay, so F was equal to, what was that? Cosine Y sine XY? So, df dx is going to be, this is going to be a product rule chain, sorry, just a chain rule. So that's going to be cosine XY, cosine Y, all times Y. And then partial F, partial Y is going to be equal to, now this is a product rule. So negative sine Y, sine XY plus cosine XY times X cosine Y. Right? Oh, true. Dennis says, hey, Dr. Gold, how you been? I'm sorry for not being able to catch the streams lately. Oh, you're all good, dude. I'm glad you're thriving, dude. Negative sine Y is the derivative of cosine. I agree. Yes. Teague says, I only have one. Yeah, sorry. In the essence of time, I don't really know how to do this question. I feel like there's some stuff that's kind of missing here. Well, they said the surface area of the region bounded by the... I'm really confused. Like, the English on this is a little weird. Like, if you want just the surface area of the paraboloid, we can do that. That's not, like, the worst thing in the world, right? That's just finding the arc length and then just multiplying by 2 pi. But the surface area of the region... FXY... This is really weird. Yeah, surface area... Yeah, exactly. That's what I would think it would be. Yeah. But what about... Sorry, how is this coming into play? Yeah, is this translated? There seems to be something like a little weird with the English. Okay, one sec. Let me see real quick. Teague, what is your question? Well, your questions are... There's a lot of questions, Teague. Which question do you need done, Teague? I can show it to you real quick. The box one. This one. Yeah, Psycho says, I don't know how to approach it either. I agree. I think it's poorly written, honestly. Okay. One sec. Well, this question's actually already done for you, Teague. Do you just need an explanation for where it comes from? They already did the question for you. You need help going through it? Okay. Well, here you go. Here, I'll explain it to you because that won't take too long. So, this is the rectangular piece of cardboard, and they say they're going to cut out, like, little pieces on the corners, because when they do that, you can then, like, fold it up from here. Do you see how, like, you would be able to... Like, this would be one of the walls, this would be another wall, this would be a wall, and this would be a wall, and then they would, like, fold up, and it would make, like, kind of like a rectangular thing. What's up, QV? Sorry, we're not sharing on Discord right now because my bandwidth is being weird. Okay. So, in order to find the volume of the box, right, volume is equal to length times width times height, okay? So, if you're cutting out squares out of each corner, right? That means that this... Well, this doesn't look very square. They kind of fucked up on making it a square, but it would look like this. This would be X, and this would be X, okay? And you would also cut out X and X here. That means the total, like... What is this? Like the total length, I guess? Yeah, the length of your box would be the full 24 minus 2x, right? Do we understand that? The length here would be equal to 24 minus 2x? Because the whole thing is 24, but then you're subtracting an x from each. And then here, this would be the full length of 36. So here the width is equal to 36 minus 2x. Okay, because you're subtracting x from here, you're subtracting x from here. The whole thing is 36. And then the height... Well, the height is just equal to x, right? Because whatever amount you cut here, it's hard to show in 2D here. If I was tutoring you in person, I'd like get a piece of paper and show you how like you cut this, and it ends up looking like this. Like, one sec. Cut corner out of paper, make box. There we go. This kind of looks like it. I don't fucking... Okay, well, this is kind of it. Yeah. Yeah, there we go. Maybe this, like, kind of shows you kind of what's happening. So you see once you, like, cut these corners out, that you can, like, fold up the sides, but that the height of this box will be the length of the corner you cut. So if you cut it out X into it, the thing stands up X tall. Okay, so once you know that, origami stream when, right? We got to do an origami. Okay, so now you know that the volume, right, is equal to length times width times height. Harshit says I got the answer. Cool. Do you want to post it in my Discord? Post it in my Discord so I can go see it. Okay, this is, right, height. This is like length. This is like width. You know the volume's equal to 1792. So then they want you to like super foil this. So this is you multiplying everything all together, okay? And then you're setting it equal to 1792. And then what you're doing is, let's see, you're setting it all equal to 0. So you have 1792 is equal to whatever this whole mess was. You move the 1792 over, and you get 0. This is calculus probably. It is optimizations. You get 0 is equal to this. Okay, this is a classic trying to find the zeros type problem. And what they notice here is that you can pull a 4 out of everything. Okay, so now you have 0 is equal to 4 times this whole thing. And you're trying to find a value of x here such that this thing equals to 0. What they do, which is kind of honest, like this is black magic here. Realizing that 4 causes this thing to be 0 is not easy to do. You're guessing. So for instance, she probably plugged in like 1 into this and saw it didn't equal 0. She plugged in 2, saw it didn't equal 0. Plugged in 3, it didn't equal 0. But then she was like, oh, if I plug in 4 for x, I do get 0. Right? Cool. So that then tells you what one of the zeros is. And wait, what is she asking for? Isn't that it? Isn't it just the height is equal to 4 then? Yeah. Yeah, what? Wait, why is she solving this again? Oh, because there's multiple solutions. Oh. Oh, this is cool. This is because there's 3 different ways you can get this volume to equal 1792. So, you know one of the solutions is when it's equal to 4. That means that this whole thing has a root of x minus 4. So you know that x cubed minus 30x squared plus 216x minus 448 is equal to x minus 4 times something else that is a quadratic, which means its highest power is x squared, because that times this will get you up to x to the third. So then what they're doing here, Teague, is they're dividing this over here to then solve for what the simpler thing is. And that's what this is. This is synthetic division. So they synthetic divide this by x minus 4 to get this, which is then x, this is x squared minus 26x plus 112. And then they're using the quadratic equation to solve for what are the other 2 values of x that cause this thing to be 0. And so now you have 3 solutions for the height. You can either have x is equal to 4, or x is equal to the solutions of the quadratic equation here, which is 26 plus or minus the square root of 223 over 2. Cool. Does that make sense, Teague? One of those solutions will be wrong, Jeff, right? Because it's probably negative and it doesn't exist. Yes, yeah. Exactly, Psycode. Yeah. So for the students that are watching, yeah, this is bullshit. This is guessing. You have to guess, and you can just like go through the numbers. Go like 1, 2, 3, 4, and just hope it's something nice. Okay, cool. Nice. Here, I'll put this. Yeah, the factor theorem. Yeah. So there's called the man. What's the name of it? It's like the possible factors or something. Someone help me out here. I run out of the names for things. I think irrational roots. Thank you, Jeff. Okay, Teague. Also, I'm going to show you this real quick. And also for anybody else who's watching here and kind of wants a little bit of help. I have a video on this, on factoring like big polynomials. It's right here, how to factor really big polynomials. This will go over how you take something that looks really big like this and then do what we just did with the like guessing the zeros and then doing the long division or synthetic division. So go watch this video. It'll help you out, and it has fun memes and sounds and stuff, and so great. But yeah. Cool. All right. That took a little bit longer than I thought it was going to. Yeah, good. You're welcome, dude. All right, let me see. Q. Lol. Let me do yours. I'll take Teagues out. Okay. Y'all asking for all these regions and these areas and these volumes. This will probably be my last question, unfortunately, because I do have to go in like 8 minutes. But again, if you're still here on the queue and you had questions and I didn't get to you, thank you for at least coming by. I will stream tomorrow as well. So if you go to the same website you went to upload your photos, there's something here called the streaming schedule. If you click on the streaming schedule here, you can see all the times that we stream, which will be tomorrow starting at 4 p.m. Pacific. Also, we have other friends like Zach, who's awesome, and he streams as well, and you can see him on the calendar. What's up? We're doing a little bit of math. All right. Let me see if I can do this real quick. Let D be the region bounded by the plane and the paraboloid. Okay, so this one at least is bounded by a plane. At least this one's bounded by z equals 0 as well. Okay. And that, find the volume of D and the Cartesian coordinates of his centroid. Oh, okay. Okay. Can I just do discs? Can I do discs here? Is that cool? Someone get mad at me if I don't do discs? Can I just like add the discs on top of each other? I think I have to do a volume of revolution though thing. I think that is actually what I have to do, right? You were meant to use cylindrical coordinates to solve this? Oh, okay. Sure. Fine. Cylindrical. Yeah, sure. Okay, so x squared plus y squared is equal to r squared. Right? And then, whatever. Z is z. Okay. So, this is something that goes up to 4, right? In terms of z, right? And then it looks like this, right? Yeah? So, your z is actually bounded by 4 minus r squared. Okay? So, in this case, if I want to do the volume, I think I'm just going to do, like what? Like 0 to 2 pi. And then it's going to be r d theta dz, right? This is the r d theta. No, it's r d theta dz, right? Is this the correct volume integral for cylindrical? Right, and z is bounded from 0 to 4. Yeah. So, sorry, we're gonna go from. Yeah, I think it's from 0 to r in terms of radius, right? And then it's 0 to 2 pi in terms of d theta. And then dz is from 0 to 4. And then, yeah, here's the cool thing, is that instead of r, right, r is going from this, watch this, you get, so, z minus 4 is equal to negative r squared, so r is equal to the square root of 4 minus z. Yeah? So you can actually bound this one from the square root of 4 minus z. So now when you integrate, so integral of r dr is just r squared over 2. So you get r squared over 2 from 0 to the square root of 4 minus z. Then we still have all this. And we still have d theta dz, right? And so that's cool. So that square is just going to kill off the square root. So it's just going to be 4 minus z. Yes, exactly, S-Love, right? Yeah, because now when I integrate d theta from 0 to 2 pi, I'm just going to pull out a 2 pi. So then we're going to get 0 to 4 of pi 4 minus z dz. And then that's going to give me 4 pi z minus z squared. My r looks like a lambda sometimes. I'm sorry. Z squared over 2. And then this is from 0 to 4, right? Okay, cool. So we get 16 pi minus 8. Cool. That should be it. I feel like that's probably the right answer, yeah? It was actually a really cool one, lol. I appreciated this one better than the other one that didn't really make any sense to me. What's up, Sam? Seems correct to me. Cool. Call it. Nice.
Well done! Well done!
The integral always causes me trouble. Yeah, no, I can see that. Okay. So here, I'm gonna put your question in, lol, into our Discord so you can go see it. There it is. Is this Calc 3? I think this is like Calc 2, honestly. Nice. Okay. We got through lol's question at least. I'm happy about that. Okay. Calc 4 minus Z. Right, okay. If you upload now, the queue clears at the end of the day. So just make sure to get on the stream when it starts tomorrow. That's the best time to do it. Cool. All right, awesome. I gotta end the stream out. All right, thank you everyone for coming out to Education Office Hours. Really appreciate all the questions today. Again, if you're wondering when we stream, our next stream will be tomorrow, starting at 4 p.m. Pacific, 5 p.m. Mountain, 6 p.m. Central, 7 p.m. Eastern. Come on through. What's up, Zach? Good to see you, dude. Yeah, shout out to Zach. Zach's an OG. Yeah, hell yeah, Zach. Very good to see you. Nice. Okay. Come by tomorrow. Have a good one. Thanks everyone for coming in. We're gonna go raid somebody. So if you're watching us on Twitch, just hang on in and we'll go see what other awesome... I added so many people at TwitchCon. So my like following list is about to be like insane. Yeah, there we go. Look at this. Mushroom Sauce is doing a stream with just like trains. Asher Canuck. There's a lot of really cool people here. Ask Me Anything. Robineering. I met all these cool people at TwitchCon. It was really dope. Boom. We are rating, yeah. And actually, I learned from some people we should probably start rating people that don't just do math and science, just like kind of expand the community. We'll go rate Asher Canuck though. He's doing a meteor shower observation stream. That's pretty cool. All right, we'll see you tomorrow. I hope you guys have a great start to your week. Peace.